Take a look, compare your work with my work. We'll slide down the page. Don't worry, it'll get more interesting. We will stop doing review of elementary school shortly. Flip the page. Okay, cool. This page. Crank them out. I know the negatives mess with people. Okay, Gabe, face the front, please. You three gentlemen. Well, but you always seem to be involved. You always seem to be involved. Okay. Flipping the page. Comments, questions, concerns on any of these things. Compare your work with mine. Going once. Twice. Thrice. Sold. Okay, cool. Quick review of multiplication and addition. Flip the page. Let's keep going. Okay. Speed up here a little. Okay, what is multiplication? Why did we introduce it? When it was introduced to you in elementary school, why did it show up? Sorry? So you can work with more cubes? I mean, maybe that's why it felt like it was introduced. There's a good reason why multiplication is a tool that we have. It's a shortcut for something. What is multiplication a shortcut for? Yes, sir. Yeah, what kind of addition specifically? Repeated addition. People got sick of adding long lists of things together. So we developed multiplication to represent that. So 3 times 2 is the same as having 3 groups of 2 things all added together. You could also write it as 2 groups of 3 things added together. It doesn't actually matter which way you go. It's either 3 groups of 2 things or added together, or it's 2 groups of 3 things added together. Either way, this is nice and easy. 3 times 2 is always and forever going to be 6. I heard lots of you mutter under your breath. So that is fundamentally all multiplication is. So let's bring in the negatives because we like the negatives. If one of the numbers is negative that you're multiplying, then we're not doing repeated addition, we're doing repeated... Nope. Repeated multiplication is exponents. Sorry? Subtraction. So the number that you have gets more and more negative. So if I have 3 times 2, what that is 3 groups of negative 2. So you can write it as negative 2 plus negative 2 plus negative 2, or you can think of it as negative 2 minus 2 minus 2. Either way, at the end of it all, if you have 3 minus 2's, that's going to be what? Negative 6. Cool. If I have negative 3 times 2, well, that's the same thing as just having negative 3 plus negative 3, or alternatively, negative 3 minus 3. Repeated subtraction. And at the end of the day, this is equal to still negative 6. It doesn't matter which one is negative, as long as only one of them is negative. We can still treat it as repeated addition of a negative or as repeated subtraction. So there's a notation, you've seen it before. You've seen this X notation 3 times 2. It's what we've been using up to this point. I don't love to continue to use this because as soon as we bring in variables, the most common variable we use in math is an X. And so now all of a sudden this X is going to get confusing when we bring in the other x. And so this is what we've been using, but we're going to start to move to some other kinds. This is what you'll see as well. If I have 3 next to a bracket, when there is nothing written in there, it's assumed to be multiplication. You can write it like this, Hayden, because it doesn't matter where you put the multiplication, but technically speaking, this is not conventionally correct. If I have something in brackets, the thing that you multiply by always goes out front. So while it's true, you're not going to see that. And I don't want you to write it that way. What we could do instead is we could write it like this, both of them in brackets. That you'll see. Gentlemen, hello. We've got a few of you. Who have I got? Ruben? No, I've got Dilkron. Yes. And, oh, is this Ruben? No, you're late. He doesn't have to move. You're late. Take an empty desk. Why are the 3 of you late? No, it only ended at 11:50 because we had a homeroom last week. Lunch ends at 11:35. Okay, so I've got Ruben rolled in here. And Sahib, is that you? Yeah. Okay. So yes, moving forward, lunch ends at 11:35. It was only late last week because of the extra long first block. So this, we could write them both in brackets. If you have things written with brackets and there's nothing between them, it's assumed to be multiplication. Or we can use the dot notation. 2.3. The dot notation and the x notation are the same at this point, but as you guys are going to, those of you who choose to go on and study further mathematics, these will not be the same. These are different kinds of multiplication. And as soon as you're multiplying other mathematical objects together, you have to do it differently. Some of you may never see it, but those of you who go off and study physics, engineering, or higher level math, you will see it there. So, anything multiplied by 0 is forever and always going to be 0. Because what does it mean to multiply by 0? Well, if 0 is repeated addition, and I multiply by 0, what this operation is telling us to do is, I want 0 groups of 3 added together. If I have no groups, can I have any numbers? No. If I have no groups, it doesn't matter what number I'm starting with. If there's no groups of them, I have nothing. So it doesn't matter if it's 3 times 0 or 0 times negative 222. At the end of the day, it's all going to be 0. Let's review negatives, shall we? Let's put it nicely down here. If I have a positive times a negative, we set it up here. If I have a positive times a negative or a negative times a positive, those will always equal a negative value. I had a student in another block asking me this about addition. This is only true for multiplication. If I multiply a positive by a negative or a negative by a positive, that result is always negative. If I have a positive times a positive or a negative times a negative, these results are always going to be, someone say it, positive. And I have an explanation for this on the next page, for why that is. So lots of these math facts are nice and easy. None of them
Please, excuse the
think are very difficult.
At this time, could grade 12 classes and their teachers head down to the Abbey Arts for the grade 12 assembly? That's grade 12 students and their teachers head down to the Abbey Arts for their assembly. Thank you.
If for whatever reason any of these math facts have eluded you, you all have a printable multiplication times tables. If you have never seen one of these things before, please let me know, but they're relatively easy to use. If I'm multiplying 3's, I find the value on the top, I find the value on the side. Where they meet is that value. I mean, obviously multiplying negatives, so 3 times 3 is 9. There are no negatives on your multiplication table, but that's fine. 3 times 3 is 9, and if I've got a positive and a negative, that result's got to be negative. So this is all should be relatively straightforward, I'm hoping. So crank out the rest of these. Someone just shout them out. What's this one? Thank you. What's this one? Because anything times 0 is 0. What's this guy? Someone said negative 35. Cool. And then this guy here is going to be negative 6. Love it. If the numbers start to get slightly larger and we've lost our time or multiplication tables, or you don't want to use them. I have some people who, in my other classes, are just still refusing to use them, and then they'll sit and stare and try and remember. Long multiplication was a tool that you learned at one point in the past. We're going to review it here real quick. If I want to multiply 13 and 2, I mean 13 times 2 should be, it could be one of those math facts that you've got memorized. You could jump to the times table. I have 2 and I want to multiply it by 13, so I'm going to get 26. Or we can do it longhand. Doing it longhand looks like rearranging it. It's often nice to write it as the bigger number on top and the smaller number on bottom. How do I multiply these things longhand? What do I do? How does long multiplication work? Yeah?
Multiply 3 by 2.
Yeah, so 2 times 3 is?
6.
Okay.
And then multiply 1 by 2.
Which is 2. Nice and easy. I mean, there's other ways you can do this in your head. There's all sorts of techniques that you can do to do this in your head. One of the things that I've seen students do, well, 13, that's just 10 plus 3. And so if I want to multiply that by 2, I can multiply that by 2 and that by 2. 10 times 2 is 20. 3 times 2 is 6. So 13 times 2 is 26. I see students do that in their head all the time. It's a relatively easy way to do it. 13 times 5, let's look at it longhand too. Lots of you will be able to do that in your head and say, well, that's going to be 65. But let's show how we get there. Doing it longhand, how does longhand change for this question? The procedure is going to start the same. 3 times 5 is? 3 times 5 is? 3 times 5 is 15. So I put the 5 down there and I carry the 1. Now when I do 5 times 1 plus the 1 is? 5 times 1 is 5 plus 1 is 6. I mean, thinking about it like this works too. But that's what longhand notation would look like. It changes when you've got multiple digits. So this is 2-digit numbers multiplied together. It's the same for even bigger values, but let's do this one. 13 times 11. Let's rewrite it as the bigger over the smaller. Now we're getting into things that I don't necessarily expect you guys to have memorized. You could jump to your multiplication table, or you can do it longhand. How does this one change compared to these previous two? How do I do a 2-digit number times a 2-digit number longhand? Who remembers? Andrew, you've got a smile on your face. Do you remember? No. If it was 1 times 13, we just do what we did before, right? 1 times 3, 1 times 1, right? So let's start that way. 1 times 3 is 3. 1 times 1 is 1. But I'm not multiplying 1 by 13. I'm multiplying 11 by 13. So there was a technique. Does anyone remember the technique from this point? Yeah. We do. We do put a 0 under the 3. Effectively what we're doing here is we're taking 13 and we're multiplying it by 1, and we're taking 13 and multiplying it by 10, and adding those two results together. 13 times 1 is 13. Multiplying by 10 is easy, because when you multiply by 10, we just add a 0 to 13 and get 130. This is effectively what we're doing here. You multiply by the 1, then you add a 0 for whatever is in this spot, and now we're going to multiply by 10. 1 times 3 is 3. 1 times 1 is 1. So now I've got 13 times 130, and now I'm just going to add these two together. It's the same as what we're doing here. So 3 plus 0 is 3, 1 plus 3 is 4, and then 100 is just 100. Or, I mean, you can look at this as well. This is the same thing. 130 plus 13 is going to give you 143. But this is what longhand multiplication looks like. Is this ringing bells? Hayden, is this coming back? Is this reminding you of things you've learned before? I know you're not paying attention now either, so I'm just trying to keep you here. But this wasn't grade 8. This would have been like elementary school or earlier middle school. Is this something you've seen before, do you think? Maybe grade 5? Okay. Okay, so let's change this question. Instead of 13 times 13, let's make it more interesting. Let's multiply 130 by 100. No, let's not do 130 by 130. Let's do 132 by 132. Let's make it more interesting. And let's do it longhand, because why not? The procedure is the same. The numbers just get a little bigger. So we're going to stack them up, and I'm going to start by multiplying 2 by everything. 2 times 2 is 4. 2 times 3 is 6. 2 times 1 is 2. And now I'm going to, because I've multiplied by this 2 already, I'm going to add a 0 there. And I'm going to multiply everything by 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 1 is 3. That's done. I'm going to add 2 zeros here now to take the space of both of those numbers. And now I'm going to multiply everything by 1. So 1 times 2 is 2, 1 times 3 is 3, 1 times 1 is 1. And now this is the mess that I'm adding together. The procedure is the same. I do it again for every subsequent number. So and now I just add the stacks. 4 and a bunch of zeros is 4. 6 plus 6 is 12, so I'm going to put the 2. I'm going to carry the 1. 1 plus 2 is 3. Plus 9 is 12. Plus 2 is 14. Put a 4 there, carry the 1. 3 and 3 is 9, plus 1 is 10. So that's a 0, carry the 1. And 1 plus 1 is 2. So 132 times 132 is 20,424. But it's the method that I want you to see. Does that kind of make sense? Does that do we remember this from times gone past? Well, give me something to work with, guys. Either we're good or this not so good. Okay. Okay, so here's my argument. Flip the page. I'm going to give you my explanation for why a negative times a negative and a positive times a negative works the way it works. Just using a different way to think about it. If you're like, I don't care why it works the way it works, I just accept that it does, well then ignore this. But for those of you who are interested in perhaps why, let's talk about it. So multiplying two negative numbers gives you a positive number every time. The question is why? Because if you think about it in terms of repeated addition, it doesn't make any sense. How can I negatively repeatedly multiply negative things? That doesn't make any sense. But if we look at positives and negatives as directions that we can move, all of a sudden it makes a little bit more sense. So I've got Pac-Man on a number line here. We can think of Pac-Man being able to move two ways. Either he can face forwards or backwards, or he can move left and right. So looking at these combinations of things is going to give us a reason why a negative times a negative is going to be positive every time. So let's look at this. This first number, in each case, is going to be the way Pac-Man faces, and this one is going to be the way Pac-Man moves in each of these examples. So if this is positive and this is positive, Pac-Man's facing positively to the right, and he's going to move 1 Sorry, and he's going to move positively. So he's facing positively, he's moving positively, and 3 times 1 is 3. So we're going to end up out here. Either it's repeated addition of 1, or it's 1 addition of 3. Either way, because he's facing positively and moving positively, our value is going to be positive. Let's look at the next one. This value here is negative 3. He's facing negatively. And now because this value is positive, he's going to move forward. So 3 times 1 is 3. And he's going to move forward from where he's facing. So he's going to end up going this way, 3. So a negative times a positive is a negative. But a positive times a negative is also negative. Well, why? He's going to face positive, but now he's going to move backwards. And if he moves backwards, we're going to be here on the number line at negative 3. And then conversely, a negative times a negative is a positive. Why? Because if he's facing negative and moving backwards, he's going to be still end up moving in a positive direction. So if you think about negatives like that, you can see why a negative times a negative is going to be a positive value every time. Now, if you're like, I don't care, I'm just going to accept it. That's great. Then let's flip the page and move on. Let's look at division. Division and multiplication are just the same as each other, just the opposites. We're going to review some long division, and I'm going to show you how to use your multiplication tables for division. Division is the process of sharing in equal-sized groups. So it's undoing multiplication effectively. Multiplication was, I want to repeatedly add this group. This one says, I'm going to take my whole, I'm going to divide it into this many groups. How big is each group? So if I'm taking 6 and I'm dividing it into 3 equal groups, well, you know fairly easily that if I have 6 things and I'm breaking them up into 3 equal groups, 1, 2, 3, 4, 5, 6. So there's 2 in each one of these groups. And so that's not 11, that's just 2 tick marks. And so what that means is that every time 6 divided by 3 is always and forever going to be 2. The same as 9 divided by 3. If I have 9 pencils shared between 3 people equally, how many pencils does each person get? Well, 3. But sometimes you're going to see division represented as a fraction, because that's all fractions are. Fractions are just statements of division, which actually makes sense. If you look at the symbol for division, that's just a fraction with a dot in the numerator and a dot in the denominator. So division is just working with fractions. So if I have 15 thirds, or 15 over 3, that's really just the same thing as 15 divided by 3. Now, those numbers are small enough that the math you've memorized should tell you that that value is what? One more time. 15 divided by 3? Yes, Andrew, I saw that hand. Was that the answer, Andrew? Yeah, it was. 15 divided by 3 is 5. And if you have forgotten that 15 divided by 3 is 5, divided by 3 is 5, let me show you how to find that on your multiplication table, because you will not get a calculator this chapter. To figure out this using your multiplication tables, we're going to go to the column that we're dividing by. So if this is 15 divided by 3, we're going to go to the 3 column. And I'm going to go down until I get to 15. And then I'm going to go over so that 15 divided by 3 is 5. That's how you'd use this table to divide something. If you want to divide something bigger, let's skip ahead for a second, like 91 over 7. You'd go to the 7 column. You'd go down until you got to 91, if you got to 91. But we do, it's right there. And then you'd go over, and you would see that 91 divided by 7 is 13. So that's how you could use your multiplication table. We're going to review long division here in a second, but let's talk about 0 first. What does it mean to divide 0 by 3? What are we actually asking it to do? Well, if we look up here, and if I said 6 divided by 3 was 6 divided into 3 equal groups, 0 divided by 3 means I have a group of nothing, and I want to divide nothing into 3 groups. How big are the groups going to be if I'm dividing nothing into 3 groups? Yes, Andrew, thank you. That's going to be 0. I have 3 groups of nothing. That makes sense. Nothing divided into 3 groups is still nothing. But this is different. 0 divided by 3, we can write that as a fraction as 0 over 3. But this one, 3 divided by 0, is 3 over 0. These are different. And this is a mistake I see all the time. 0 divided by 3 is 0, because 3 groups of nothing is still nothing. But this one is different. This one says I have 3, and I'm trying to divide by 0. I'm trying to divide 3 into no groups. Does that mathematically make sense? Can I divide something into no groups? So last class was like, well, no, you have 3. Well, no, I don't, because I don't want to have any groups. So if I have 3 things, I'm not going to put them into any groups. Does that make sense mathematically? I have 3 objects, and I want no groups of them. It shouldn't make sense mathematically. And so we have language around this. We say that when you try and divide by 0, you're trying to take an object and divide it into no groups. We say that this is mathematically undefined. If you plug it into your calculator, when you will be one day allowed to use your calculator again, often your calculator will say this as an error, or they might say math error. But the reason it's telling you that you've got an arrow is because this is dividing by 0 is not a defined mathematical operation. We have no, that isn't a thing. And so that's what it spits out. So real quick, let's review long division, shall we? Okay, I'm going to do 2 of these, and then I'm going to free you to play. Who remembers long division? Who remembers hating long division? We don't like it as a tool, but sometimes it's still useful, so let's review it. If I want to take 24 and I want to divide it by 2, your math facts that perhaps you've memorized will tell you that 24 divided by 2 should be 12. Let's show that using long division. Here's how long division plays out. When I want to long divide, I take the thing that I'm dividing and I put it in this symbol here. And I take the thing that I'm dividing by and I put that number out front. And now we talk about this object going into this object to make groups. How many times does 2 go into 2? Does 2 go into 2? Goes in once. Thanks, Andrew. So then I put how many times this number goes into this number above this number. I say, okay, well, 1 times 2 is 2. I multiply it back over this way. 2 times 2 is 0. And now I'm going to bring down my next digit. Does 2 go into 4? Yes, it goes in. Charlie, was that this many times? 2 goes into 4 twice. So I put the 2, as many times as it goes in, above this digit. And now I'm going to multiply. 2 times 2 is 4. 4 minus 4 is 0. So that 24 divided by 2 is 12. That's it. If it doesn't go in nicely, well, we have ways to add decimals to things, but at this stage, that's what we're going to look at. Let's do one more. One that isn't quite as clean, but still works out. Let's look at this one. We used this one, 91 over 7. I showed you how to use your times tables for this, but let's do this one again using long division. I'm taking my 91 and I'm dividing it by 7. And the procedure here is going to be the same. Does 7 go into 9? Yeah, it does. It goes in once. Because 9 is bigger than 7. Hayden, what are you doing? This is the third time I've seen you get up. Okay. Yeah, don't worry about it. I'm on it. So 1 times 7 is 7. 9 minus 7 is 2. And I'm going to bring down the 1. Does 7 go into 21? It does, Gabe. How many times? 3 times. So then 3 times 7 is 21. 21 minus 21 is 0. So 91 divided by 7 is 13. That's it. This is just going to be a review of multiplication and division. If we get done in time, we'll launch into BEDMAS. So, flip the page. This first page, I just want you to tell me, for the first 3 questions, I just want you to tell me if the final result is going to be negative or positive. Don't do the math. Just tell me if the answer is negative or positive, depending on how many negatives are being multiplied together. These ones, I actually want you to do the math. And then I want you to crank out this table. I don't expect this to take very long. So, do these last 4 questions. 1, 2, 3, 4. And then I want you to do the next 2 pages. At 12:35, we're going to move on. So crank these suckers up. Yes, sir. You may. Class ends at 1. So, but we are going to look at BEDMAS today. Actually, there's a lot of BEDMAS practice. You may. Oh shoot! I totally forgot to get him to do this. Here's what I want you to do. Okay, I'll just bring this up to everyone. So Hayden and Liam are both leaving the classroom right now. They're underneath that big number 10 over there on the wall. There's now a section on the board for people who have left the classroom. So Hayden, if you could erase Duden's name off there, because he's in a different block. Put your name on there when you leave. When you come back, erase your name. So Hayden, if you could put your name and Liam's name on there. And then when you guys come back, erase your names off the board. Okay, there you go. Get to it. Okay. Yeah, man.
When I get like disappointed.
So then you're gonna, oh, where's my pencil? Oh, it's right here. So then like for this one? So then for this one, you did 2 times 4 is 8, subtracted 0, you brought down the 4. Now how many times does 4 go into 4? Once. So then you put the 1 up here. 1 times 4 is 4, 4 minus 4 is 0. Sorry, computer. What do I do with this guy? What's happening here? I've got a fraction. I'm adding, I'm multiplying, but I've got something going on here in the numerator. Does someone take a guess? What do I deal with this? Yes, Krishan? You're right. First I do the equation on the top and then I divide. When you have a bunch of stuff written in the top portion of a fraction, it's the same as if all of that stuff had brackets around it. So when there's brackets around it like that, this is what you set up, and you do the math that's inside there first. So 10 plus 3 is 13, minus 1 is 12. So that's the change I've made. I'm going to write that down. So it's now going to be 12 over 6 plus 2 times 2. I made one change. Below it, I wrote down what I changed, and this is how I want you to set this up. And now we can do the next pieces. We did the brackets. I added the brackets, and then we did them. There are no exponents. The multiplication and division. I've got division here. I've got multiplication here, and they're separated by addition. So what we're going to do is we're going to divide these two and multiply these two in the same step. You're allowed to do that. So 12 divided by 6 is 2. 2 times 2 is 4. And the addition that's happening between them stays as it is. And on my last step, 2 plus 4 is 6. I want you guys to get into the habit of changing 1 or 2 things at a time, writing your math below what came previously, and only jumping to the right-hand side of the equal sign when you've got a final value. Okay, you got 15 minutes left. Here's what I want you to play with. Flip the page. There are 40 questions on the next 3 pages. Yeah, 40 questions. I want you to do I'm going to assign the odds today. And that is how we're going to end the last 15 minutes. So if you haven't finished the multiplication division stuff, go back, finish that. Jump to this. You got 15 minutes to crank a bunch of these out. You can do it. I believe in you. No calculator, but you've got your multiplication tables, and those should prove to be useful. On your market set, giver. And I'll float around as needed. Remember, we've got Shabat on the side who's happy to help. I just have to get up and move towards him. Okay, and for the sake of the video, I did start the dead mask and forget to unpause. So this is all we did. That guy there, and that guy there. And now, one sec, and now.